multi-wheel knot remover and tightener. Their advisors, Engineer Gustoli Asi and Engineer Felbert Castañaday. Presenting the proponents, Carlos Gabriel Alcuas, Bon Cedric Greco, Justin Jeron Rehuso, Rian Luis Santos, and Renz Christian Sona.
A pleasant morning to everyone. My name is Rian Santos, and on behalf of my group mates, I will present to you our thesis or our study entitled Development of Android-Controlled Multi-Wheel Knot Remover and Tightener. According to an annual report by the Land Transportation Office in the year 2016, almost 51% or approximately 900,000 private vehicles were registered. And from this data, it can be known that there are really a long list of advantages that we can have when we have a private vehicle as a mode of transportation in our country. And then when you own a private vehicle, there are certain factors to be considered, especially for periodic maintenance services, and one of the factors to be considered are the wheels. So, in the United States, the statistic shows that every driver will experience an average up to 5 flat tires in their lifetime, and that is almost about 220 million flat tires per year. And according to a survey by Spector on the year 2016 indicates not all car owners know how to maintain their unit and cannot change tires. That is almost 57% of it knows. They said that they were quote-unquote clueless about changing tires. So these are the following objectives of the study, and it will be further discussed on the following slides. So with this existing problem, with additional of innovative knowledge and collaborative thinking, the proponents came up with the idea of the development of the Android-controlled multi-wheel knot remover and tightener. So this prototype is used to the study is developed in aiding users in changing tires, specifically automatically controlling it, it automatically remove and tighten the lug nuts simultaneously. And this prototype is intended for vehicles with 4 lug nuts with 100 mm pitch circle diameter. So this is the block diagram, and as you can see, we use Android application for the control of the prototype, Bluetooth module or Bluetooth as the connection between the software and the hardware, which is the microcontroller, relay for relaying functions to both motor and the LED lights, and then the whole system is powered by lithium-ion batteries. So for the machine design, this is the sample layout of the design wherein the proponents, the mechanical engineering of our group designed this one, and the proponents designed the gear ratio inside of the device to have a gear ratio of 1:2. The stand is designed with 0.25-inch distances between each steps for adjustable stability, and the main shaft is designed to be removable, so each of the socket can be easily installed with the wheels lug nuts. So this is a sample application layout, screen captured from an Android phone. The following layout is developed through an iterative development way of development. The first picture shows the connection. The second one is for the list of bird devices for connecting a new device. The third one is just a notification for the user. The fourth one is the controls, the control page or the activity, and the last one is the exit dialog. So this design is tested and evaluated using the following standards like efficiency, reliability, functionality, and usability. The efficiency is tested through mechanical advantage, or this is the advantage gained using mechanical machines in order to apply force, and time efficiency compared to the conventional way of removing and tightening of the lug nuts. And for the validation, we conducted survey with 100 respondents. Specifically, those respondents have driver's license and which are selected through the use of expert sampling. So for our efficiency testing, this is the summary of our tables. This test is for mechanical advantage. It shows the ratio of the input force by the user to the output force of the machine. So this is just a summary, and this test is conducted, it has a beta test which is conducted by 5 different people with different driver's license type, gender, height, and age, and they use it on 2 different vehicles, which is specifically the Honda Jazz 2016 model and the Ford Fiesta 2011 model. And the following output would be, for removing and tightening of the vehicle A, we have 2.7 times and 2.1 times efficient in terms of removing and tightening respectively. And for the use of vehicle B, it is 2.8 and 2.2 times efficient in removing and tightening using the vehicle. The next one is the time efficiency. So we tested, we used the time in conventional way as the experimental time value, and the use of the multi-wheel nut remover manually and automatically as the actual time value. So these are the output time. It's just also a summary, and we concluded that the use of the multi-wheel nut remover and tightener manually for removing is 10% faster than the conventional way, and tightening of the lug nuts is at least 38% faster than the conventional way. Next one is the testing of reliability, and the proponents concluded that the system or the prototype is reliable with a maximum distance of 12 meters. And then the functionality, this test is used on the evaluating the prototype as a whole system. So these are the sample survey questions in the survey questionnaires and survey that we have conducted. So this preliminary research is considered as a preliminary research for future innovations, and the success of the group and all collaborative groups in this colloquium shows or exemplified that knowledge in different fields can be used in the field of mechatronics, and it solidifies what we can have or what we can do in the future through development, innovation, and technology. So that's all. Thank you for listening.
Let's take a look at the video.
Have you ever experienced driving and suddenly something's not feeling right? And went outside and found out that you had a flat tire? You are in a hurry and felt disgusted and immediately started to loosen the stubborn lug nuts until your tire haggard. But you only just removed the flat tire. Worry no more. Introducing the Android-controlled multi-wheel lug nut remover and tightener. Thanks to its thought-modifying technology, it can loosen and tighten wheel lug nuts in no time with less effort. It features an adjustable stand with 30 points of variable height. With a rotatable magnet sockets and main body for ease of socket positioning. With a waterproof headlamp and hazard light for lifetime usage. But wait, there's more. Did I say that? It is cell phone controlled. Connected via Bluetooth connection, you can control the loosening and tightening action in the lights of the device in the palm of your hand.
Time is up. I think we have to cut the video. Thank you very much. Anthony. Now it's time for question and answer. Okay. Now we have technical panel, Engineer Manguera.
Morning. Morning. Good afternoon na pala. This is a very interesting research, no? Kasi this last week, I personally rotated all my 4 tires habang nasa garahe. And in my 14 years of driving, no, I maybe at least once a year nagpapalit ako ng gulong. Mechanical-wise, it's good. Pinakita niyo naman na you have shown that it has really gained a mechanical advantage compared to manually. I know a lot of people that would personally like this device. First question is, maybe I think hindi man masyadong issue, pero I think the Android part is parang masyadong overuse. No? You use a computer that is capable of doing thousands of calculations just for a switch. No? Where you can just incorporate a switch, a red or green button, doon sa mismong device niya. That's all. No? If you have tried to personally change a tire, and you have seen your video that there are many times that you have